Calorimetry is a really important MCAT topic, and we're going to cover everything that you need to know. And if you like these videos, check out the link in my bio for over 500 pages of images and typed out explanations just like these. Starting off, we have this large container, and the walls of this large container are insulated, so ideally no heat can leave the water that's inside of the container. Within the large container, we have a smaller container, and this time heat is allowed to leave from inside that small container to the surrounding water. In a perfect system, this means that the heat lost from the small container is going to be equal to the heat gained by the surrounding water. This is important because it allows us to use the temperature change that occurs in the surrounding water to calculate the heat gained by the water, which then we can use to calculate the heat lost by whatever is happening inside of that small container. The thermometer here is going to measure the change in temperature of that water. So that gives us the delta T. When we set up this experiment, we are going to measure out the mass of the water. And then the specific heat of water, which we used a variable C, is equal to 4.2. So we combine the data we get from the thermometer with the mass of the water and the specific heat of water in this equation, Q equals MC delta T. And this allows us to find the heat gained by the water. And like we said before, that heat gained by the water is equal to the heat that was given off by the container within the water. If you have a reaction taking place in that container, you can take the heat lost by that container and divide it by the moles of reactants, and that can give you the heat given off per mole of your reactant. Now be careful, because sometimes you are not given a perfect system, and some heat is actually going to be lost out of the large container if it's not perfectly insulated. What that means is the heat given off or lost by the small container, that's going to be equal to the heat gained by the water plus the heat that left the larger container right here.